Let's talk about graphing cotangent. Now, cotangent is undefined where the line segment is horizontal, since the cotangent of x can be thought of as cosine of x over sine of x, and we know that sine of x is equal to 0 at 0 and pi. So both of these give us undefined values for cotangent. Now I'm going to go ahead and fill out the rest of this table really quickly. Okay, so I filled out the rest of the table and I filled in some values on my xy plane. Let's go ahead and fill in where the vertical asymptotes are, and that is going to happen at pi and at 0. And now if I start to graph this, I know that pi over 2, my output is 0. At pi over 4, my output is positive 1. At 3 pi over 4, my output is negative 1. And so my graph is going to look something like that. And it almost looks like the mirror image of tangent kind of like reflected over the vertical axis, but also notice that the vertical asymptotes exists at different locations as well. And so if I were to sketch a quick graph of a few more periods, it'd look something like that. Okay, this definitely turned out better than my tangent graph. Okay, so now we want to talk about the domain. And the domain, or the vertical asymptotes, are going to happen at integer multiples of pi. So x cannot equal n pi, where n is an integer. And the range, similar to tangent, is going to be all real numbers. So here are some general guidelines that you would want to use when you are trying to graph tangent and cotangent functions in general. Recall that the period is pi over k, and you want to locate two adjacent vertical asymptotes by solving the following equations for x. So depending on whether you are doing tangent or cotangent, you are going to set them equal to different things. And we'll go over examples of what that looks like in just a moment, and then you can read through the rest of the steps. So here our k value is 1/2, and if I wanted to start off with the period, I know that that would be equal to pi over k. And in this case, k is equal to 1/2. And so if we simplify that, that ends up being 2 pi. That means that the distance between my two vertical asymptotes is going to be 2 pi. And let's talk about how we are going to figure out what our asymptotes are. So you have 1/2 x, and you set that equal to pi over 2. And then you can also do 1/2 x and set that equal to negative pi over 2. And when you solve this for x, this will give you your two vertical asymptotes that are adjacent to each other. So to solve for x, I can just multiply by 2 on both sides of the equation, and then those will cancel out. And so here we get x equals pi, and then same thing on this equation. I multiply both sides by 2, and we end up getting x equals negative pi. And that ends up working out so that our vertical asymptotes are here, and notice that between negative pi and positive pi, that distance ends up being our period, which is 2 pi. So I will draw in my vertical asymptotes, and then I will put in my x values so that I have split up this interval into 4 equal parts. Okay, so if I plugged in pi over 2, so I have y equals -3 times tangent of 1/2 times pi over 2. That's going to end up simplifying to -3 times tangent of pi over 4, and that equals -3 times 1, which will end up being -3. So I'm going to go ahead and plot that here. If I plug in 0, I know tangent of 0 is 0, and then multiplying that by -3 will still make that 0. And if you end up plugging in negative pi over 2, it's going to look like that. And now I can go ahead and I know what the general shape looks like. And it's going to look like that. Okay, I just couldn't live with myself because my graph was so ugly, so I had to improve that. And let's go ahead and talk about our amplitude. Our amplitude is the absolute value of a, and in this case a is -3, so our amplitude is going to be +3. Our period we solved for earlier, and we found that that was equal to 2 pi. And our phase shift, you can either say like not applicable or 0, either of those is fine. And then for the domain, since our period is 2 pi, the next vertical asymptote would be at 3 pi, and then the one over on the negative side would be -3 pi. So basically, we cannot have odd integer multiples of pi. And so one way that you could say that is x cannot equal 2n plus 1 pi, where n is an integer. So that is one way that you can say the odd integer multiples of pi. And then the range is going to be -infinity to +infinity, or all real numbers. So that concludes example 2a. Part B wants us to graph y equals 1/2 cotangent of 2x plus 1. So the amplitude is the absolute value of a, and in this case a is 1/2, so the absolute value of that is going to be 1/2. Our period can be found by doing pi over k, and in this case pi is, k is 2, so our period is pi over 2. There's no phase shift happening, so that's going to be 0. The domain and range, let's figure that out once we have graphed this. Now, because this is cotangent, we want to set the thing inside the parentheses equal to 0 and equal to pi, and then solve those. So if I divide both sides by 2 here, I get x equals 0, and then here if I divide both sides by 2, I get x equals pi over 2. So those are the locations of my two adjacent vertical asymptotes. So here's one at 0. And then here is my other one at pi over 2. And then let me go ahead and fill in some more values. Halfway between 0 and pi over 2 is pi over 4. Halfway between 0 and pi over 4 is pi over 8. And then halfway between pi over 4 and pi over 2 is 3 pi over 8. And let's see, our amplitude is 1/2. So let's say that's 1/2. That is -1/2. And I know that we are also shifting up all of the points on our graph by 1 unit since we have a +1 outside of the parentheses. So I'm going to make note of that y value there at 3/2. And so why don't I sketch the graph of just y equals 1/2 cotangent of 2x, and then we can shift up 1 from there. So I know that if I plug in pi over 4 for x, then I'd have cotangent of 2 times pi over 4, and that's going to be 1/2 cotangent of pi over 2, which that's going to simplify to 1/2 times 0, which is 0. So that's going to be 0. If I plugged in pi over 8, that's going to be 1/2. And then if I plug in 3 pi over 8, that's going to be negative 1/2. So the graph is going to look something like that, but I want to shift all of my points up by 1 unit. So let me graph this in a different color. I'm going to shift up, up, up. So this is going to be here, my new point. This is going to be here. And now my graph is going to look something like that. Something like that. And now we can talk about the domain and the range. So if I drew another vertical asymptote on this side, this would be at negative pi over 2, and then the next one would be at negative pi, and then on this side, the next one here would be at positive pi. So we would say that the domain is all real numbers except integer multiples of pi over 2. And then the range, as we can see, is all real numbers. And that concludes graphing one period of this. If we wanted, we could do a rough sketch of maybe 2 more periods, but it looks something like that.